just went over how the answer to number 1 was G. Alright, so let's go on to example 2. Or example 1b. We have two equations written in standard form like this, ax plus by equals c. It's hard to tell much about their slope and their y-intercept. So, and then if we look at our answer choices are all talking about the y-intercept because it says this one is below and this one is above. Okay, so what I'm going to do is I'm going to take each equation and solve them for y. So I've got 6x plus 3y equals 12. That looks like a G, and I'm sorry. And then 6x plus 3y equals 36.
So it's both of them?
Yeah, we're going to solve both of them for y and then compare them. Okay, so tell me please how to solve this first equation for y, please, Corey. This one right here. Okay, you subtract 6x from both sides. So that cancels. That leaves me with 3y equals negative 6x plus 12. What's the next step, Corey?
Then.
Don't be nervous, buddy.
Okay.
You know this, right?
Mhm.
Okay, so then y equals negative 6 divided by 3 is negative 2x, and then plus 4. Alright, now next equation, solving it for y.
Subtract 6x.
Okay.
36 and you get 3y equals negative 6x plus 36 divided by 3 will be negative 6 over 3x.
Which is what?
We need
6 over 3. Intercept is at plus 4. Oh my goodness, it's hard to do this without a stylus. And then on the other one, my y-intercept is plus 12, which would be a lot farther up on the line. 6x plus 3y equals 36 is 8 units above the graph. From 4 to 12, that's a difference of 8. So that's got to be my answer. Alright, if the graph of a line has a positive slope and a negative y-intercept, what happens to the x-intercept if the slope and the y-intercept are doubled? So I'm looking for, the only thing that concerns me this time is the x-intercept. Now, it didn't give me any equations of lines this time. So what I'm going to do is I'm going to make up my own equation that fits the criteria. It's going to have a positive slope and it's going to have a negative y-intercept. Okay, so again, I'm just going to make this up. So equation 1, if I give it a positive slope, let's say y equals 2x, that's a positive slope. And a negative y-intercept would be, say, minus 8. No, I got to make it smaller because I'm about to double it. So let's make it minus 4. Okay, so if I were to graph that line, so 1, 2, 3, 4, apply my y-intercept, and then a positive slope of 2 over 1. I'm looking for the x-intercept, so I'm going to go ahead and plot that because I'm not very good at drawing lines. So at least I'll know what point my line is supposed to go through. So there's my line 1. Ish. Okay, so line 2, it says the slope and the y-intercept are going to be doubled. So that my new equation is going to be y equals multiplying 2 times 2 would give me 4x. And then my y-intercept is also doubled, so it's going to give me minus 8. So if I plot those points on the line, starting with my y-intercept, 1, 2, 3, 4. And then my slope is the same, right? No, it's not. It's steeper. It's up 4 over 1. So I go up 4 over 1. I'm going to go up 4 more over 1 because that's my x-intercept. And I notice that if I look at just the x-intercept, grab a highlighter here, it's the exact same point for both lines. It didn't change. So then my answer choice is, that's wrong, that's wrong, that's wrong, it's got to be the x-intercept. Alright, example D, it says, which statement best describes the relationship between the graphs of these two equations? And then when I look at my answer choices to try to see ahead just a little bit, it's asking me for perpendicular, parallel, same y-intercept or same x-intercept. How can we tell if two lines are parallel or perpendicular without having to graph them?
That would be the same slope,
Good.
but two different lines.
Okay? Now, does that ring a bell? Help you out with perpendicular at all?
What is perpendicular?
And like,
Your slope has to be the negative reciprocal. Okay? Now, in order to tell the y-intercept, that means my b has to be the same. X-intercept, I'm just gonna have to either plug in numbers or graph it. So, we'll do that later, depending on what we need to do. So, I'm basically need to look at what my slope is and what my y-intercept is. I already have equation 1, solve for y. But I need to do that for equation 2, so it's easier to compare the slope. So I'm going to start with 3x plus 2y equals 12. Alright, so if I solve that equation for y, I'm just going to subtract 3x from both sides. So 2y equals negative 3x. Corey, you're going to be up next. Plus 12. What would be the next thing to do if I'm going to solve for y? Let me do it. Let me do it.
maybe up and then it out.
Yeah, if I have the equation 2y equals negative 3x plus 12, and I want to solve the equation for y, what do I do?
Right?
By,
2.
good. Feeling a little bit better. So y equals negative 3 halves x plus 6. Okay, so when we compare our two equations, I gotta erase my slope for the first one is 2/3. My slope for the second one is negative 3 halves. I'm also going to highlight my y-intercept. It's negative 4 and positive 6. Okay, knowing that, let's just go through our answer choices and see which one is true. So, letter A, the graphs are perpendicular, which means that we have to have a negative reciprocal. Do I have a negative reciprocal there, so are they perpendicular? Yes, they are perpendicular. So, the answer would be A. We can stop right there. It says the student is expected to state direct variation. So that's what I want for you to highlight is direct variation. And I can't do it on my thing, but I would like for you to highlight that on your paper. Direct variation for linear functions and then solve problems involving proportions. Alright, I'm going to give you a formula and I want everybody to write it down. When you have direct variation, what that means is you have an equation that can be written as y equals some constant a times x. And that letter a is a constant and stays the same for every single x and y value that you have. Basically what that means is if x goes up 2, y is going up 2. If x goes down 3, y is going to go down 3. And that a tells you how much they're going to go up or down. Let's start with example A. It says if y varies directly with x, and y is 14 when x is 6, which of the following represents this situation? So basically what it's asking us is what is the relationship between x and y? In order to do this, I'm going to take my equation y equals ax, and I'm going to plug in my x and my y. Y is 14, x is 6. So if I plug that into my equation, I've got 14 equals a times x, which is 6. Now I can solve for a, which will give me my constant. So we're going to divide by 6. If I divide both sides by 6, that gives me a equals 14 over 6, which if I simplify that, that's going to be 7/3. Okay, now I can take that value and plug it back into my equation. So y equals a is 7/3 times x. So my answer is G.